Good morning, everyone. Today's class, we're going to see the third part of three-dimensional geometry. In this class, I'm going to cover shortest distance between lines. If you have watched my previous two videos, I have completed till 13 sums of exercise 11.2 in my previous video, where equations of lines were covered and angle finding between the lines was also covered. So today we're going to do shortest distance between them. Now, shortest distance between the lines. Two lines in a space can be intersecting at a point, can be parallel, or it could be neither intersecting nor parallel. So just imagine a space. Well, there could be, many lines in it, right? There will be infinite number of lines. Now, some of the lines are intersecting. So what will be the distance? No distance. No shortest distance between intersecting lines. Then the lines could be parallel. Then what happens? If the lines are parallel, the shortest distance is the perpendicular distance. And now the third category, which is neither intersecting nor parallel. The lines which are neither intersecting or nor parallel called as non-coplanar lines or skew lines. They're called as non-coplanar lines or skew lines. And therefore, the lines which are either intersecting or parallel are called as coplanar lines. I'm repeating this one more time. A line which is either intersecting or parallel is a coplanar line. A line which is neither intersecting nor parallel is a non-coplanar or a skew lines. For intersecting lines, no distance. For parallel line, the perpendicular distance is the shortest distance. Now let's see the formula. Now when the lines are coplanar, which means they are parallel, alright, because intersecting does not have a distance. So coplanar lines and they are parallel. So when there are two lines which are parallel, then how do two lines parallel look like? The Cartesian equation of two lines that are parallel will look like this. R vector equals A1 vector plus lambda times B vector. And R vector equals A2 vector plus B times plus mu times B vector. Now, since the lines are different, they have a separate passing through points. A1, A2 are the respective passing through points of those lines. Whereas B vector will be the same because lines are parallel, direction cosine is same, the direction vectors are same, right? When lines are parallel, they have the direction vectors are lambda times of each other. So one is lambda times of the other, or we can say it is proportional, right? So B vector will be the same. So we take B vector from the line, we take A2, A1 as from the equation, which is their passing through point, and then we apply it in this formula. Now, when the lines are non-coplanar, which means skew lines, how do they look like? R vector equals A1 vector plus lambda times of B1 vector. R vector equals A2 vector plus lambda times of or mu times of B2 vector. Now here the lines are skew lines, which means B1 and B2 would be different vectors. So we take B1, B2 from the equation, we identify A1, A2 from the equation, and then we apply it in this formula. Okay, B1 cross B2 dot A2 minus A1 by magnitude of B1 cross B2. Now technically in a plane, this is how two non-parallel, non-intersecting line will look like. That is the lines which neither parallel nor intersecting. Diagonal of a roof and the diagonal of an adjacent wall. So this is how two skew lines will look like. Okay, but I hope I don't have to show intersecting and parallel. You can definitely identify that. Now let us take sums from the NCERT to try this concept. Now we need to start from question number 14. Question number 14 is finding the shortest distance between the lines. But are the lines coplanar or non-coplanar? Well, just see the B vector. The B vector are different vectors. They are not proportional to each other. B1 and B2 are not proportional to each other. Therefore, these are skew lines. So the distance that they want us to find is the distance between skew lines. And now, when you see the book, there are many formulas depending upon the form of the equation. When the vector form of the equation is given, we have a formula for that. When the Cartesian form of the equation is given, we have a formula for that to find the shortest distance. But if you ask me, that is a bit too much to memorize. So don't go for all that. Just learn the formula that I stated in the board now and try to change the given equation to the comfortable form. For example, the first one, the 14th one, is a vector form. So this is the most comfortable form if you're in, or you should be able to connect or relate these two forms. For example, like as I said, the 14th one, 14th one, this is my passing through point, A1 and A2. This is the direction vector, B1 and B2, correct? Now, if you take the Cartesian form, where will we find the passing through point? These are the passing through point. So that means A1 vector would be minus 1i or minus I, minus j, cap and minus k cap. Correct? Because when you convert vector to Cartesian form, I did show how to do that in my previous video. So see that and try to relate it. So never learn too many formulas. Just try to develop yourself based on, just apply one formula. Try to change the question or take information from the question in order to apply it in that formula. So here A1 vector is minus I minus j minus k. B1 vector will be the direction vector, which is 7i minus 6j plus 1k. So there is a cap. Likewise, for the next line, A2 vector is 3i plus 5j plus 7k cap, and B2 vector is I minus 2j plus k, isn't it? So whether a vector or a Cartesian form is given to us, it doesn't matter. Just see whether B1 is proportional to B2. That is, B1 is lambda times of B2. If B1 is not lambda times B2, then the lines are skew lines. So take A1, A2, B1, B2 from the given equation. Whether it is vector or Cartesian, we know how to take it. Then simply apply it in the formula. And if B1 becomes proportional to B2, that is B1 is parallel to B2, then you use the distance of parallel lines, that is coplanar line, the one that I gave you now. Okay, now let me try the 15th sum and show you how to do it. 15th question from the NCERT textbook. The question is x plus 1 by 7, y plus 1 by minus 6, z plus 1 by 1, and x minus 3 by 1, y minus 5 by minus 2, z minus 7 by 1. Let me check once again. So x plus 1 by 7, y plus 1 by minus 6, z plus 1 by 1, x minus 3 by 1, yes. Now, as I said, let's take the A1, A2, B1, B2 from this. So A1 vector is I cap minus I cap minus j cap minus k cap. B1 vector equals 7i minus 6j plus 1 k cap. Similarly, A2 vector is 3i plus 5j plus 7k cap, and B2 vector equals I cap minus 2j cap plus 1k cap. So we found A1, A2 and B1, B2. Now we understand that B1 is not proportional to B2. So that means they are skew lines. Therefore the lines are skew. So now we need to find the shortest distance between the skew lines, where the formula's distance is equal to B1 vector cross B2 vector dot A2 vector minus A1 vector divided by magnitude of B1 vector cross B2 vector. So this is the distance. Now how do we find B1 vector cross B2 vector? B1 vector plus B2 vector, we find it using determinant ijk 7 minus 6 and 1, 1 minus 2 and 1, right? So now let's take the determinant I cap times of minus 6 plus 2 minus j cap 7 minus 1 plus k cap minus 14 plus 6. So we get minus 4 I cap, 6 j cap, and 14 minus 6 is minus 8 k cap. So minus 4 I cap minus 6 j cap minus 8 k cap. That is B1 cross B2. Let's find the magnitude of B1 cross B2 vector, which is root over minus 7 root over minus 4 square, which is 16 plus 36 plus 64. So we get root 116, which is 2 root 20, which we get it as 2 root 29. Okay, now we need to do A2 minus A1, right? A2 minus A1. So what is A2 minus A1? Let us see what it is. There we go. So here it is A2 minus A1. 3 plus 1 4, 5 plus 1 6. See, this is A2 and this is A1. So A2 minus A1 is 3 plus 1, because 3 minus of minus 1, 5 plus 5 minus of minus 1, 7 minus of minus 1. So 4, 6 and 8 is what we get. This is A2 minus A1. Now do the dot product of B1 cross B2 dot A2 minus A1. So that is minus 4i minus 6j minus kk into 4i plus 6j plus 8k. So we get minus 16 minus 36 minus 64. So we get minus 116. Distance equals root of magnitude of minus 116 by 2 root 29, right? Or we can say this as root 1116. So if you cancel, the answer would be root 1116 29 units. Since distance cannot be negative, the modulus will take out the minus. Okay, so this is how we find the distance between skew lines. Understood? Now see the 17th question. Well, 17th question is neither of vector form nor of Cartesian form completely. But it is in vector only, but not in the standard form, okay? So let's group the terms. R vector equals the ones that doesn't have t and the other that has t. So I'm grouping the one that doesn't have t. So I cap plus, minus 2j cap plus 3k cap. So these are terms which will give you terms which is without t. Without t, yeah. So minus 2 into j and then 3 into k. Alright, plus t times all the coefficients of t. So minus I cap plus j cap minus 2k cap. So like that you can separate for the next one also. R vector equals the one without s and with s. So let's group the ones which does not have s. So I minus j minus k plus s times of I plus 2j minus 2k. Okay, now it is evident that the equation is in the proper vector form wherein the A1 vector, or A1 vector is the passing through point of the first line and B1 vector is the direction vector of the first line and A2 vector will be the passing through point of the second line, B2 vector will be the direction vector of the second line, and therefore you can apply it in the formula that I just showed it to you. So this is shortest distance between lines. Hope you understood. Work out all the sums. Don't learn too many formulas. Stick to the basics. You will find this chapter very interesting. Thank you.